Good evening, Jay. This is Chris Mahoney. Looking forward to working with you tonight. I wanted to give you this quick video just to get started as we look at moving between rational exponents and square roots or radicals. Just a little bit about myself. As you can see, I'm sporting my Sarah High School sweatshirt. I work with a lot of kids from Sarah High School, from Menlo, and so just have a connection to the Bay Area from when I used to live there with my family. We lived in San Carlos. And so one of the things I do right now, in addition to working with high school students, is I do a lot of work with college athletes. I work with a lot of freshmen and sophomore students who are student athletes who go to Division I schools. I'm really close to Duke University and the University of North Carolina at Chapel Hill. So I do work with some of the football and basketball players there. As well as I got a couple of athletes in Boston area as well as in Texas. So I do work with a range of students, and I'm looking forward to working with you. So I just wanted to give you a little bit of background. I'm assuming you play sports, so I'm sure we'll have that as a connection. But anyway, let's get started. All I wanted to share with you here is very simply that you can easily move between radicals and exponents by looking at how the power or the exponent is set up. So as you can see here, sorry about that, I get text messages constantly. I don't know why it's not turned off. So as you can see here in your notes that you have, where it talks about looking at the square root of 9, if we were to write that as sorry about that. If we were to write this as an exponent, we're going to take the power, okay? Because when you have that square root, such, and let's make it real big here real quick, all right? The square root of 9 is actually, if you were to write it correctly, has this little 2, oops, that was terrible, has this little 2, like right in here, okay? And that 2 tells you that you're doing a square root. So it's the opposite of squaring a number. So if I were to write the square root of 9 as an exponent, I would write 9 to the power of, I'm going to put a 1 as the numerator, and I'm going to put the 2 as the denominator, because the denominator here applies to what kind of root it is, whether it's square root, cube root, to the 4th root, etc. And the numerator just tells you whether you're doing it to the 1st power, 2nd power, or 3rd power. Okay, so for example, if I had the square root of 9, it would be 9 to the 1/2 power. If I had the cube root of 27, now they've got negative 27 here, but let's just say cube root of 27. Okay, if I were to have that, then either the 3 would be on the inside, and so your power, whatever the solution is going to be 1/3. Okay, if I had an equation that looked like, I'm going to draw this one real quick. The square root of the square root of 49, but then it had parentheses. I just got to make it a little bit larger. Well, actually, let's draw them in parentheses. And the power was to the, let's say it was to the 3rd power. Okay. The way you would write this is, if you were to write this in exponent form, is going to be 49 to the power of, the 2 is what the denominator will be, and the power up here is what the numerator will be. So that would be 3/2. So what this means is you're going to take the square root of 49, whatever that value is, in which case is 7, and then you're going to cube it. And once you cube it, you realize that you get 343. Okay, and so that's sort of the quick and dirty on how you maneuver between exponents and square roots. Now, one thing that will be really helpful if you don't know this is to really have down in a solid way your perfect square values, because these will really help you. So for example, if I asked you the first 15 perfect square numbers, I would expect you to go like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Can you see that? 1 squared, 2 squared, 3 squared, 4 squared, all the way down to 10 squared. And then I expect also 121, 144. Now that's 12 squared, which most people know. The one you have to learn is 13 squared, which is 169. So I think of it as 13 is, I just add the 2 3s, so it's 1, 6, and then I multiply the 3s, 9. Now 14 squared is just like 169, except you flip the 6 and the 9. So 14 squared is 196, and then 15 squared is 225. You will have a much easier time in this unit and in math going forward if you have these first 15 perfect squares solidly memorized. It'll be really helpful, not just in what you're doing here, but further on down the road. Now, and this is what we'll talk about when I show up in a few minutes, that you have notice you have some square roots that are negative, and oftentimes you're told, well, you can't square root a negative, and that's true. You can't square root a negative because that would be what we call an imaginary number or a complex number. But you can cube root a negative because, for example, negative 27. Well, the square root of negative 27 would be negative 3, because negative 3 times negative 3 times negative 3 equals negative 27. Whereas if it's a positive, like the square root of 16, it's going to be both 4 or negative 4. Okay, and in earlier grades in math, they often just give you the positive square root, but in reality, like the square root of 9 is really, we just say plus or minus 3. Okay, plus or minus 3, because it can be either 3 or negative 3. Okay, so when you look at your work here, where it's talking about simplifying these radicals, okay, so for example, if you look at example 6 here, negative 27 to the 2/3, and I'll leave this here for you. So that 3 tells you, what does that 3 tell you? It tells you that it's a cube root, right? And then what does the 2 tell you? The 2 here tells you that it's going to be to the power of 2. Okay, so I'm going to stop here at example 6J just so that you can use this to get started. We'll look at the more complicated problems together. But again, in terms of a fractional power or a fractional exponent, the numerator, start with the denominator. The denominator tells you what root it is, square root, cube root, etc. And the numerator tells you to what power are you raising it. Okay, 2/3 is going to be a cube root to the power of 2. 3/4 is going to be the 4th root to the power of 3, and so on. Okay, so listen, it's great to finally connect, and I'm sorry about last night, but let's change that up and let's get started today and just kick some butt, because this is clearly things that I bet you are able to do. All right, thanks again, Jay. We'll talk to you soon. All right, bye.